Okay, I am Dr. Babu, Professor and Head of the Department of Biomedical Engineering, Sri Sanmuga College of Engineering and Technology, Salem. Now, I am going to explain about the risks associated with the electrosurgery. So, in continuation with the diathermy, electrosurgery techniques in diathermy, what are the risks associated with the electrosurgery that we can see in this class? Okay, safety aspects in the electrosurgery units. Okay, what are the risks associated? That is, first risk associated is burn. Okay, burns, electrical interference with the heart muscles that leads to ventricular fibrillation. Next one is danger of explosion caused by the sparks and the electrical interference with pacemaker and other medical electronic equipment. So first, burns caused by the excess current density. Burns caused by the excess current density. So always we have to use the current density low level, as low as possible. Burn occurs at the dispersive electrode because of failure to achieve adequate contact. The injury can also occur because an unintended current pathway. A lesion occurs at a point where the patient is inadvertently touching a grounded object and the contact is made over a small area of skin. These are some of the risks. Okay, next one is presence of moisture, that is, the accumulation of prepping agents, blood or other fluids around the indifferent electrode can give rise to small, highly conductive areas. Burns from small conductive areas between the limbs. Okay, the presence of moisture, that is, the accumulation of prepping agents, blood or other fluids around the indifferent electrode can give rise to small, highly conductive areas. Burns from small conductive areas between the limbs can be prevented by means of dry cloth placed between them. During surgery, the output power of the electrosurgical unit should not be increased if the desired surgical effect is not obtained. So, in many cases, people are doing the mistake. If the surgical effect is not obtained, they keep on increase the power of the surgical unit. So, that should not be done. Otherwise, the problem arises. It is advisable to carry out surgical work with the power setting as low as possible to reduce the risk of burns. The active electrode, when not in use, should be placed well clear of the patient. This is to avoid its activation in case of the foot switch is inadvertently pressed. So these are the burns associated risk and some of the effective measures. Okay, next high frequency hazard. So generally we are using the high frequency only for the surgical diathermy. We are using the high frequency only in terms of 1 MHz to 3 MHz. Another serious hazard associated with the use of the surgical diathermy machine is the possible electrocution of the patient from faulty mains operated equipment when one side of the electrical circuit is connected to the earth. In order to provide protection against main current electrocution, a capacitor is generally included between the indifferent lead and the earth. Okay, this is for high frequency. The output configuration plays an important role in the radio frequency current circuit. There are three technical approaches. One is earthed output system, earth referenced system, and the isolated systems. The value of the capacitor is such that while providing a very low impedance to the high frequency diathermic current, it offers a higher impedance to the mains frequency. This approach also offers only a partial solution to the complex problem. Modern solid-state diathermy machines usually have isolated patient circuits. This implies that ideally RF current may take only one path, that is, from active electrode through the patient to the indifferent electrode. Okay, so this is the diagram explains about the high frequency current hazard. Okay, so diathermy machine. This is the diathermy machine output circuit, which is connected to the active electrode, which placed on the tissue which is to be cut or coagulated. This is the indifferent electrode. In between the active and indifferent electrode, the patient or tissue will be available, and the machine is grounded via power cord. So this is for the protective measures. So this is another diagram. First A, B, C. In the earthed output system, the indifferent electrode is connected conductively to protective earth. Figure A. Conductively to protect the earth. So then B, there is a small difference. The earth reference system, this is called earth reference system, uses a capacitor to connect the indifferent electrode to the earth. So while we are connecting to the earth, we are connecting a capacitor to the indifferent electrode to the earth. Okay. In figure B, this permits RF currents to flow to the earth through the diathermy machine, effectively blocks the passage of low frequency current, that is 50 years. So capacitor allows high frequency and blocks the low frequency. So that's why while we are attaching the capacitor, it blocks the low frequency of 50 years line frequency. It allows the high frequency to the ground. In the isolated system, the third one is isolated system. The return electrode is floating. That is, there is no intentional connection to the earth. That is, the RF leakage current is due to stray capacitance within the machine. Okay, there is a capacitance here C1. It is not actual capacitance, it is a stray capacitance. So this stray capacitance, the current due to this stray capacitance will be grounded. The case of the machine is grounded, so that stray capacitance will be grounded. These are the current hazard and the protective measures. Okay, next high frequency current hazard. In continuation with the high frequency current hazard, since there is no earth connection, there is no propensity for the RF current to take any earth pathways which may unintentionally develop. However, due to RF leakage pathways inherent in the equipment and the leads, no machine can be considered as completely isolated. This is the important point. Due to the RF leakage pathways inherent in the equipment and the leakage, no machine can be considered as completely isolated. There will be always some leakage current. The degree of RF leakage current is a measure of the degree of isolation of a particular machine. The lower the leakage current, the better the isolation. With the current technology, RF leakage of around 100 milliampere are generally achieved. So this is the data. The leakage current 100 milliampere are generally achieved. Of the three types of electrosurgical output systems, earthed reference and isolated, only the last two are recommended by IEC in 1978 standard. The surgical application in which the danger of ventricular fibrillation cannot be excluded. Electrosurgical units of the isolated output type CF should be used as they offer the best protection against the fibrillation. Earth reference system type BF are recommended for most general applications. The voltages of the power transformer in a surgical diathermy machine are high enough to cause serious injury. Okay, so these are some of the high frequency current hazards. Therefore, when checking voltages, it is advisable to take adequate care. Also, caution should be taken to avoid damage to the test equipment due to high voltages and high current. Okay, next explosion hazard. Explosion hazard. In operating theatres, danger zones can develop through the use of cleansing agents such as ether and alcohol, and by using explosive anesthetic gas or mixes with oxygen. The sparks associated with the use of surgical diathermy can cause a dangerous explosion because of this explosive anesthetic gas, ether, alcohol, like that. So there should not be any spark. Because of this spark, it can cause the dangerous explosion. The use of non-explosive anesthetics such as nitrous oxide, fluorothane or halothane is recommended to prevent spark. If inflammable gases are used as anesthetics, the electrosurgical unit be located outside the zone in which it is used. So to avoid the explosion. The foot switches of the electrosurgical unit should be explosion proof. These are some of the measures. Some diathermy machines are fitted with automatic anti-explosion devices. When the foot switch is activated or the fingertip switch in the electrode handle is operated, this device causes a stream of nitrogen to emanate from the electrode handle to form a protective cloud around the cutting and coagulating electrode before the high frequency generator is switched on. Okay. Hence, the explosive gas mixers in the immediate vicinity of the electrode cannot ignite. In automatic control is incorporated in the unit, which ensures that the high frequency current is not switched on until the active electrode is surrounded by the protective gas. After the gas is surrounded, then only we have to use the high frequency current. This is achieved by using an electrically heated thermistor in the handle, which gets sufficiently cooled by the flow of protective gas. This ensures that an adequate stream of gas is emanating from the handle. So these are some of the hazards and preventing the explosion, preventing measures taken to avoid the explosion. Okay, this is the end of our today's slide. Thank you.